Section 1.5 is all about problem solving. Yep, that's right, story problems. We'll see story problems throughout this section that you should approach with a 4-step plan. We're going to do the first problem here, and I'll explain to you each of the 4 steps. You are designing the layout for a newspaper about teen issues. The newspaper will be 22.5 inches wide and 30 inches high. You plan to have 5 columns with 1/8 inch gaps between them and 3/8 inches margins on the left and right sides. How wide will each column be? You should start each problem like this by reading and understanding the problem. So again, we read it. Sometimes it might take a couple reads before you really get a grasp of what's happening. So as you're reading it, we need to first focus on what do you know and what do you want to find out. So as we go through this, I'm seeing that we're designing the layout for a newspaper. Do we need to know it's about teen issues? Not so much. The newspaper will be 22.5 inches wide and 30 inches high. I don't know about you, but as I read this, I'm starting to think that maybe a picture would help me out. So again, I'm going to lay out a newspaper 22.5 inches wide and 30 inches high. So I'm kind of picturing this in my head, getting ready to draw what I need to draw. You plan to have 5 columns that are 1/8 inch gaps between and then 3/8 inch margins on left and right. So in order to draw the picture, I let the computer do it for me because you'll find that Mrs. Hawkins has the art skills of about a 5-year-old. So here's what the picture would look like. So you see here, I have the columns and the newspaper laid out before us. We have 22.5 inches on top and 30 inches long because it said 22.5 inches wide and 30 inches long. And then here's my 5 columns, 1, 2, 3, 4, 5. Each of them needs to be 1/8 of an inch in between and then 3/8 of an inch on each side. So moving back to our plan, we have identified what we do know by drawing the picture. The second part of the first step is to identify what do we want to find out. That always comes from the question part of your problem, which typically, I would say 90% of the time, shows up at the end of the problem. So in this case, it says, how wide will each column be? Moving on to the next step is where we need to make a plan. The good news is we always want to first identify what our variable is going to be equal to. But like I said, the good news is your variable is always going to be representing what you wanted to find from the question part of the first step. So in our case, we're going to let W equal the width of each column. After we've defined the variable, we should then set up a verbal model of what our equation is going to look like. So basically we're going to lay out our equation first in words, so then when we go onto the next step, we'll just have to solve the problem. So going back to the original problem, we know that our equation all has to do with the width. So I know in the end my equation has to be equal to the total width of the newspaper since I'm trying to find the width of each column. So that's what I'm going to set out first. I'm kind of working backwards here. So again, I know that my final equation should be equal to the total width of the newspaper. So let's go look back at our picture. So looking at the width here, we see that the total width of the newspaper is 22.5 inches. And that's comprised of the number of columns, which in this case is 5, times how much each column is, the width of each column, which we don't know yet, that's what we're trying to find, plus all of the in-between. So we have all of these 1/8 and the 3/8. So here again, our equation is going to look like the number of columns that we had times the width of each of them, and then we're going to add up all of the in-between spaces. So all the spaces in between each column, and then the margin lengths on each side. So coming back to our plan, just like we said when we were referring to the picture, we're going to take the number of columns that we have on the newspaper, time the width per column of each column, and then we're going to add up all the spaces in between, and again, all of this added together should equal the total width of the newspaper. So moving on to step 3, let's actually write the equation now. So we have 5 columns times the width per column, which we were just representing with W as we stated in step 2, plus all the spaces in between. If you remember, we had 4 1/8 inches in between each of the columns. So we have 1/8 plus 1/8 plus 1/8 plus 1/8. So those are all the spaces in between each column. And on each of the sides, we had 3/8. And so what's nice is when we're adding fractions, we want a common denominator, which in this case, they're all 8. So we just have to add the numerators. So adding all these together, we have 1 plus 1 plus 1 plus 1, which is 4, plus 3 is 7, plus 3 again is 10. So we have 10/8. Let's make that easier to use and say 8 goes into 10 one time with 2 left over. So 2/8 is the same thing as 1/4. So all the spaces in between each column, including the 2 margins, is equal to 1 and 1/4. Let's just change that to 1.25, just so we can work in decimals here. And so we know that all of that width, all those widths combined, have to be equal to the total width of the newspaper, which in our case was 22.5. So I'm just going to change that to 22.5. Notice we are not using the 30. Is that okay? Absolutely. We're only talking about the width here, not anything about the height. So that 30 inches, just like the fact that the newspaper is about teen issues, we don't have to use that. Which that is a common thing in these problems, is they'll put these distractors in thinking that you need to use each of the numbers, when in actuality you don't. So solving this, we would first subtract 1.25 from both sides. I'm going to run into our last step here, but you'll get the idea. So we have 5W equals 21.25, and then we're going to divide both sides by 5. So we'll end up with each of the columns should be equal to 4.25, and that would be inches. And then the last step is always to look back at your answer. Does it make sense? Is it a feasible answer for you to think that each column is 4.25 inches? And one way to do this is just to take your answer and substitute it back into your equation. So this was our equation. If I substitute, and I can just do this with a calculator, if I put 4.25 back in for W and take that times 5 and add it to 1.25, I will still get that 22.5 that I needed. So always in that last step, go back and make sure your answer makes sense, and also you can just substitute it back into your original equation and see if it actually works out. There are also 4 formulas that you're going to need for this section. The first one has to do with temperature. It's where we need to convert Fahrenheit degrees back into Celsius. Let's see what it looks like. It will start with Celsius, so C equals 5/9 times F minus 32. So again, C is representing the Celsius degree and F represents the Fahrenheit degree. The next equation you're going to use is the simple interest formula. So this is dealing with money. Let's look at what that formula looks like. So there's your formula. I equals P times R times T. I is your interest, so how much you earn back. P is your principal amount, which is the initial amount. So if it says that you invested $500, that is your principal amount. R is your interest rate, which should always be expressed as a decimal. So for example, if you're told that you have a 5% interest rate, like this, you would actually put into the equation 0.05. You move the decimal point 2 places to the left. If you were told that you have an interest rate of like 1.25%, moving the decimal point 2 places to the left would be 0.0125. And then the last part is T, which is time, and that always has to be in years. So if it said 3 years, you'd put 3 in for T. If it said 6 months, that's actually half of a year, so you'd put 0.5 in for the time. The next equation has to do with distance traveled, and I'm sure you've seen this equation before. It is simply just D equals R times T, where D equals the distance. In this case, the R represents the rate in terms of speed or your velocity, and T is time. And in this case, T can be any time. It could be minutes, it could be hours, it could be seconds, it could be years, it could be months, anything like that. And then next and last equation is profit. So you can find profit by this equation. P equals I minus E. So P is the profit, I is your income, so how much you actually brought in, and then E is your expenses, because let's say you spent $200 making blankets for a craft show and you brought in $500. So your profit would have been 500 minus your expenses of 200, so your total profit, the amount you actually bring home, would be $300. So let's put these equations to use. The first example, one day the temperature in Rome, Italy was 25 degrees Celsius. The temperature in Dallas, Texas was 86 degrees Fahrenheit. Which temperature was higher? It's not fair just to say, well, Dallas was 86 degrees and Rome was 25 degrees, because Fahrenheit and Celsius are not comparable. So let's convert the 86 degrees Fahrenheit to Celsius. For each of these problems, always identify what equation you're going to use first. So write it down. The equation we're going to use here was where we convert Fahrenheit into Celsius. So C equals 5/9 times F minus 32. So in this case, we're taking the 86 degrees, which is Fahrenheit, and converting it into Celsius. So I'm going to put the 86 degrees in for the F. So I have C equals 5/9 times 86 minus 32. Following the order of operations, I need to take the 86 minus 32 first, since it's in parentheses. So C equals 5/9 times 54. And then I wouldn't panic here, the fact that I got to take 5/9 times 54, because if you just think about 54 being over 1, you can do some cross simplification. 9 goes into 54 6 times, so it really just leaves me with 5 times 6, which is 30. So this would be 30 degrees Celsius. So going back to the original problem, it said Rome was 25 degrees Celsius, and now we know Dallas was 30 degrees Celsius. The question was, which temperature was higher? It was Dallas, so Dallas was hotter. Example number 2, Jerry is borrowing money from a friend at a simple interest rate of 4%. If she borrows $2,000 and plans to pay it back in 2 years, how much interest will she owe? So again, start off every problem by writing down the equation that you're going to use. In this case, I see it's a simple interest problem. So our equation is I equals P times R times T. So the question was, how much interest will she owe? So we're going to be looking for I. They tell us that she borrowed $2,000, so that's the principal amount, the initial amount that she borrowed from her friend. The friend is charging her 4% per year, so that's going to be our rate. But remember, the rate has to be expressed as a decimal, so we're going to say 0.04. And then she needs to pay it back in 2 years, so that would be our T for time. So substituting all of these into our equation, we would start with I equals 2,000 times 0.04 times 2. Punching all that into a calculator, I end up with I equals $160. Notice I labeled it with dollars because that would be the amount of money that she ends up paying her friend for borrowing it. So not only will she have to pay back the $2,000, but also $160 just for letting her use the money during the 2-year time. Example number 3, a migrating whale is traveling at an average speed of 5.4 kilometers per hour. How far will the whale travel in 18 hours at this rate? So I'm seeing all these things like average speed, 5.4 kilometers per hour, and 18 hours. So I know that I'm going to be using my distance formula. D equals R times T. So it tells me that she's going 5.4 kilometers per hour. So that would be the rate, the speed. And it tells me that she has traveled for 18 hours. So I'm going to put 5.4 in for R and 18 in for T, and that would give me the distance. So 5.4 times 18 ends up giving me 97.2. Since the 5.4 was in kilometers per hour and then it was 18 hours, I know that my label on this would be kilometers. Example number 4, our last problem. Sky sells baskets that she weaves from sweetgrass. She makes a profit of $68 and her expenses are $2.50 per basket. How much did she charge for each basket if she sold 8 of them? So I'm seeing things like profit and expenses. So I know that I'm going to use my profit formula, which is P equals I minus E. So remember, the P represents profit, I represents how much she brought in, so like income, and E represents expenses. So it tells me she makes a profit of 68. So that would be our profit, P. And then it tells us that her expenses were $2.50 per basket. Per means to multiply, so we know that it's $2.50 times the number of baskets she sold, which was 8. $2.50 times 8 is 20, so our expenses, E, would be $20. So substituting these into our equation, we know that P equals 68, and we're looking for the income minus the expenses, which was $20. So I would just add 20 to both sides. So she ended up bringing in $88 worth of money for selling the 8 baskets. That would mean if she sold 8 of them and she brought in $88 total, but you just need to take the $88 divided by 8, the number of baskets that she sold, to end up finding how much each one cost. So 88 divided by 8 is 11. So each basket she charged $11 for. Make sure you wrote down all of the equations, the Fahrenheit Celsius, the simple interest, the distance formula, and the profit formula in your notes so that you're able to use those when it comes time for any quiz or any test. And also make sure you write down any questions that you have that you can bring to me in class tomorrow.